Hello friends, I am Nkejan from Skill on Tech. Today I will explain you about parallel operation of centrifugal pump, their characteristics, various combinations and selection of motor for parallel operation of centrifugal pumps. Parallel pump operation is a very common practice in industries. Parallel pump operation is done where a huge flow requirement exists. Parallel operation or parallel pumping of two centrifugal pump is mode which allows pump operation to be controlled by starting or stopping one of the two pumps, means standby system. In process industries, they have a standby system. Two similar pumps are installed. If by a chance for taking maintenance of one pump, then other pump will taken into line for meeting the process flow requirements. If two centrifugal pumps A and B are operated in parallel, the flow rate QA plus B. So here you can see this is a pump A and this is a pump B. So discharge of both pumps are going into one common manifold here. So the flow of pump A and B will be QA plus QB. But the head of the pump and discharge manifold will remain same. Whatever head developed by pump A will be available in the common discharge, and the head developed by B will also be same in the discharge manifold. So HA plus B equal to HA barabar HB. Parallel pump operation. Here you can see in the picture that two pumps are installed in parallel. Both pumps are identical, pumping half of total design flow, means same flow rate, and producing same pressure head. The head developed by pumps are same. In the discharge manifold, total flow will be sum of the flow of both the pumps. In figure 2, we can see how we have to get operating point in basic parallel pump operations. So we can see here in the x-axis this is a flow rate, and here in the y-axis this is pressure head in feet and flow in gallon per minute. So you can see this is a HQ curve, this curve, and this is a system curve. Then this will be the basic operating point of a single pump. So we will get this flow for a single pump, and this will be the head, operating head, and this is a shut off head at this point number 1. This is a shut off head. In this slide we will see parallel pump curve construction. So if both pumps are operating, the system flow will be determined by the combined action of both pumps. To construct the composite paralleled pump curve, select several values of head on the single pump curve, double the flow at the head and plot the points. Connect the points to determine the combined effect of both pumps in parallel. So let us see in the picture. This is a single pump curve. This is H head and this is Q. So this is a characteristics curve of HQ curve of a single pump. Now in the parallel pump operation, when two pumps are placed in parallel, so what we have to do, select several values of head on the single pump curve. So here these are the several values of head. Here you can see double the flow. So this is a flow of a single pump, and here it is doubled. Now connect the points to determine the combined effect of both the pumps. So here in this picture you can see both the pumps. This is a curve for a single characteristics curve of a single pump, and this is a characteristics curve of parallel pumps. Now you can see in this picture, this is a head in feet and this is a flow. Here you can see this is a curve of a single pump and this is a HQ curve of a characteristics curve of a double pump. So if this is a operating point for a single pump, as we have seen in the earlier slide, then this will be the flow we will get and this will be the head. But when we operate both the pumps in parallel, then we will get this flow and this head. So this is a procedure to construct characteristic curve of a parallel pump operations. Parallel operation, flow and head. You can see a picture where two centrifugal pumps are parallelly operated. The pumps are A and B and both are having stable characteristics curves. So in this case both the pumps are identical, means both are having same shut-off head. The actual flow rate and head of pumps operating in parallel. Operating point is the intersection of the common pump and system characteristics curve. Here what we can see in this picture, this is a characteristics curve of pump A, this is a characteristics curve of pump B, and this is a characteristics curve of A plus B. Suppose this is the system head curve, this, then here we will get this is the intersection point with this system head curve, and our flow will be Q dot A plus B and head will be here. But in case if this is the system head curve, then this will intersect characteristics curve here at this point, and this will be our flow rate QA plus B, and the operating head will be this. Pump A and B are having shut-off head HQ, and in combined operation also we are having the same shut-off head, and their combined characteristics curve intersect with the system head curve at somewhere other point and operating at a lower shut-off head from their original individual shut-off head of the pumps, then pump will operate in a stable condition. All centrifugal pumps are equipped with a check valve in their discharge and thereafter in downstream equipped with a isolation valve. The problem is opening of the check valve. If pump will operate lower than their shut-off head, opening of check valve is not difficult because both the pumps are operating at the same head which is lower than their shut-off head. Centrifugal pumps running in parallel will operate without any problem if their characteristics curve are stable and both have the same or almost the same shut-off head. Parallel operation with different shut-off head. Here you can see in the picture that two pumps are installed parallelly with different shut-off head. Here you can see this is a pump A with HO A shut-off head, and this is a pump B with HO B shut-off head. In case of parallel operation of centrifugal pump with different shut-off head, a operational care is required to make them trouble-free operations. This is a characteristics curve of pump A and this is a characteristics curve of pump B. So this is a system head curve and this is a system head curve for both the combined pumps characteristics curve, this A plus B. So if pump is operated here and this is the operating point, then we will get a trouble-free operation and we'll get a flow rate QA plus B, and head will be this much. But in case when we operate the pump here, this point, so when we operate both the pumps parallel, then this pump A will immediately reach to shut off head, and pump B will continuously pump, and pump A will not pump because it will not be able to open its check valve, because the pressure head is little higher because of pump B is under operation. So in that scenario, what we have to do, the pump A must be started first, let it open the check valve, and then pump B shall be started. So then we will have a stable operation of both the pumps in parallel operation. If the flow QA plus B decreases to Q dot A plus B, so in that scenario, the operation at different point here will make it troublesome if care will not taken for starting the pumps. So the starting sequence of the pumps shall be that pump A shall be started first, and then pump B shall be operated thereafter once pump A is stabilized. Parallel pumps with unstable characteristics and same peak head. In case of two centrifugal pumps A and B with unstable characteristics curve and the same peak heads, parallel operation is possible in the range 4 to 5, where any further pump of the same characteristics can cut in without any problem. So here you can see in this picture, this is a characteristics curve of pump A, this is a B, and this is a combined curve. This is the point number 5 and this is 4. So if system had curve this cut here at this point, both the pumps can be easily operated in parallel operation, because the shut-off head of both the pumps is higher and the operating head is here. So both pumps can be easily operated, and we will get this flow QA plus B, and head will be here, operating head. At point 4, here also, if system head curve is this, then this will be the operating point. This is also the operating head is here. So here also we can continuing trouble-free operation of parallel pumps at point number 4, because head is operating head is H0. But here this parallel operation is not possible at point number 1, 2 and 3, and here at 0, because in these operating ranges the pump whose shut-off head H0, this is smaller than HA plus B, would not be able to open the check valve because of the pressure exerted on it by the other pumps. So in this case, where the shut-off head H0 is smaller than HA plus B, then that will be not able to open the check valve, and the parallel operation will not be possible. So therefore, it is very important where we have to operate the parallel pumping with unstable characteristics, and what is the head, operating head, where we have to run the pumps in parallel. Parallel pump with unstable characteristics and different peak heads. So here you can see in this picture that two pumps are under operation, pump A and pump B. The peak head of pump A is here, and pump B is here. So this is shut off head of pump B and this is shut off head of pump A. So here it shows unstable characteristics curve where the peak head H peak of pump A is higher than that of pump B. As soon as the head at the operating point HA plus B is higher than the smallest value of the peak head H peak B. So here you can see in this picture, this is a characteristics curve of a two parallel pumps while under operation. Then you will get this HQA plus B flow, and this will be the, suppose this is a system head curve, then this will be the operating head will be achieved, which is similar to H peak B. So both the pumps can be easily operated in parallel. But when we operate the pump other than this area, this is a parallel operation is possible in this zone, but parallel operation will not be possible in this zone, and here in this zone we will get a transient flow parallel operation pattern. The pump with the smaller shut-off head HOB, this one, will not be able to open its check valve against the pressure of the other pump H0A, because in this region discharge pressure delivered by the pump A will be higher than the head developed by the pump B. So pump B will not be able to open the check valve. So it will be difficult to operate the pumps in parallel. Therefore, we have to start the pump B first and then we have to start the pump A. And parallel operation trouble free is possible only in this zone, which is shown here. So this type of constraint can lead to interruption in pump operation and should be eliminated by meticulous planning right from the start. If parallel operation of two pumps is not specified, it is easier and less costly to design a double suction pump instead of using two separate centrifugal pumps to meet the process flow requirements. Combination of centrifugal and plunger pump operation in parallel. If a plunger or piston pump and a centrifugal pump are operated, the flow rate of the piston plunger pump QK, which is almost constant over the head, is added to the centrifugal pump flow rate QA. And this is our centrifugal pump characteristics curve. And this is our combined characteristics curve of centrifugal pump and plunger pump. And this is our system head curve. So then this is the operating point where we will get this head, operating head, and this Q K plus A flow of both the pumps combined under operation. Let us understand motor selection for parallel pumping. The motor for a pump in a parallel pumping application must be large enough for the HP required when it is the only pump running. Means the motor shall have a sufficient horsepower requirement to meet the single pump operation requirement. If this is not done, the motor may shut down on overload or fail when the system goes to single pump operation. For this reason, it is important to analyze the worst case horsepower requirement and provide a motor that is large enough to meet that requirement. In simple application, the worst case point is shown as point C in figure. So let us see in the figure how parallel pumps are operated. There are two pumps. So this is a single pump characteristics and this is a double pump characteristics. So when double pumps are operated, and this is a system curve. So pump is operated at point A when this is under parallel operation, and this is a point C when pump is under single pump is under operation, because the system head curve will intersect here for a HQ curve of a single pump. So this is point C is the place where single pump will operate. Here you can see in this figure, the BHP increases during single pump operation. So how? In figure shown, the three parallel dotted lines represent line of constant horsepower. These lines 1, 2 and this 3. When both pumps are running, each pump operates at point B, the system at point A. So this is a system curve and this will intersect here. But both pumps are running at point B. Each pump is using horsepower little less than 40 horsepower. A designer may have selected a 40 horsepower motor with a service factor of 1.15, a typical general duty motor that could provide as much as 46 HP operating at the limit of its service factor. 40 into 1.15 equal to 46 horsepower. So we are having a motor of 46 horsepower. Suppose, then what will happen if we need to operate a single pump? During single pump operation with no change to the system, the single pump will run out to the point C. So when only one pump is under operation, system head will intersect here. Then this is the point C is the operating point. And the power line shows the power requirement is 50 horsepower. This one. So when pump will operate at point C, the power requirement will be slightly more than 50 horsepower, causing the 40 horsepower motor to exceed its service factor and overload. Hence, motor will be tripped on overload. So therefore, while selecting a motor for parallel pumping, we must select a motor of a suitable rating and a horsepower to meet the requirement of single pump operation. Thanks for watching the video. If you like this video, hit like button below, share it with your friends and colleagues, subscribe our channel for getting updates on upcoming videos. Please leave any comments, feedback to improve the videos. Thank you.